Hey everybody, one more quick video here for chapter 13 containing a couple of problems worked out for you. There's really only maybe two or three different types of problems, really two formulas that you're asked to make use of in chapter 13. And you'll see it several different configurations of problems surrounding that. The most basic is what you see here, CAPM example number 1. This is right out of the textbook. Uh, Very basic story. We're told about a stock that has a beta of 1.15. We're told the expected return on the market, that RM, market average return, is 10.3%, the risk-free rate 3.1%. What must the expected return on the stock be? This is the basic application of the CAPM, trying to find what rate of return investors should expect from a particular investment given the level of risk, given the beta of 1.15. Taking our inputs, you probably want everything in decimal form here, not percentages. Makes things simpler. 3.1% is 0.031. That's the risk-free rate. That's the minimum rate of return on any investment. The market average return is 10.3%, or 0.103. That's the average return, or the return on an investment of average risk. We were told that this particular stock's risk, or beta, is 1.15, so it's a little bit riskier than average. Its risk premium will be a little bit larger than the average, or the market risk premium. You can see the calculations here. You have the CAPM formula from the notes, previous video, and so forth. The rate of return required on a security is the risk-free rate plus the market return minus the risk-free rate multiplied by beta. 3.1% plus the market risk premium times this particular stock's beta. The calculations here come out to this. In parentheses, you would have, I don't know what's in parentheses, but when you multiply by the beta, you get 0.0828 added to 0.031. This stock should be returning about 11.38% to its investors. Again, it's a little bit riskier than average because its beta is larger than 1. Therefore, the return that's expected, 11.38%, is a little bit more than the average return on stocks in the marketplace. Very similar example here is number 2. Same sentiment, same type of question. I made it a little bit different because of what's given to you. Very similar structure. We're told the risk-free rate is 3.5%. Here's something different. We're told the market risk premium is 5.5%. What does that mean? Well, market risk premium is the quantity inside the parentheses, the RM minus RF, the difference between the market average return and the risk-free rate. I've got those assumptions here. 3.5% is the risk-free rate of interest. The market average risk premium, or what we call the market risk premium, is 5.5%. We were told that Hazlitt Incorporated has a beta of 1.65. So when you plug all these things together, again, the risk-free rate plus the market risk premium in parentheses times beta gives us the result. You can do the math, but this one turns out to be about 0.1258 or 12.58%. Again, this stock is considerably riskier than average, the beta of 1.65. Therefore, the return expected on it is considerably higher than the market return, which would be 9%. You might see problems like this one. That's this third one here, Jensen Shipping. You might see these on occasion where you're asked to use the CAPM to solve for variables other than the required rate of return. These are not very practical problems usually. They're kind of puzzles, but you do encounter them from time to time. Again, just plug the variables that you know into the equation and do the math to solve for the result. Here we're told that Jensen Shipping has an expected return of 17%. The market return is 11.8%, and the risk-free rate is 4.8%. What is the beta? Here we're solving for the beta given the expected return that we already know. Taking the inputs, we have 4.8% is the risk-free rate, that's RF. The market return, 11.8%, is RM. The return on this stock, RI, is 17%, 0.17. Plugging the variables into the CAPM, 17% on the left, that's the required return on this stock. 4.8 is the risk-free rate. RM, market return is 11.8 minus 4.8 here, times beta. Beta is what we're solving for. And again, you can do the math. I've got got it restructured here, but the answer comes out to be 1.7429. This is not surprising. Again, the return on the market for this example is 11.8%. That's the average return on risky investments. This stock has an expected return of 17%. It's much higher than the average, so I would expect the beta to be considerably larger than 1, and sure enough it is. That is a pretty high beta. The last category, the other category of calculations you might encounter in this chapter, have to do with finding the beta of a portfolio. Remember, a portfolio is just any combination of 2 or more risky assets collected together. 2 stocks, 3 stocks, 500 stocks. They could all be considered portfolios. So here we have an investor forming a portfolio by investing $50,000 in stock A, which has a beta of 1.45, $25,000 in stock B, which has a beta of 0.76, and asked, what is the beta of the overall portfolio? Well, first thing to notice is that we have the betas, 1.45 for stock A, 0.76 for stock B. Those are the individual stock betas. To get the answer, you have to calculate a weighted average. The beta of a portfolio is just the weighted average of the betas of the stocks held inside the portfolio. What do we mean by weights, or what do we use for weights? Well, think about it. This investor is investing $75,000 in total, $50,000 in stock A, $25,000 in stock B, $75,000 in total, $50,000 of which is in stock A. $50,000 out of the $75,000 total is 0.6667, 2/3, 66.67%. We'll usually express those as decimals. That's the fraction of the overall portfolio occupied by stock A. The rest of the portfolio here is, well, with $25,000 that's invested in stock B, and again, it's the same denominator. 25,000 out of 75,000 is 0.333, or 1/3. Weighted average is pretty simple to calculate. You take the weight of stock A times the beta of stock A plus the weight of stock B times the beta of stock B. Make sure you do your multiplications first, then your addition. The result here should be exactly 1.22. If you're having any trouble getting these answers, reach out to me and ask a question. I'm happy to provide some help. Usually it has to do with just the order of operations and getting things plugged into the calculator right. But again, I can help you with that.